This is the Empower Podcast. Released June 25th, 2023. Episode 637. CH32V003 Fun with CNLohr. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm CNLohr. I've got a YouTube channel and do a lot of online open source and open source hardware work.
Welcome, CN. You are doing some awesome stuff. And in fact, you are doing stuff that I kind of always wish I would have done, namely like do anything with that CH32 part. And we're definitely going to talk about that here. So thanks for not only showing the world what you're doing with the CH32 part, but also building some tooling around it.
Yeah, it was the CH32V003 was kind of the first time I looked at one of these cheap Chinese devices in the world of like Giga devices and Poya, and I was like, this is it. This is the one. And when I looked too, there was really no good tooling around it. It was either the proprietary SDK, which was really overburdened, or like the platform IO, which was also overburdened. I was like, no, I think that this is the time to act if we can make some tooling around this to really open up the power of the chip while this is hot. Like, I think a lot of people are going to have a lot of fun with this.
I actually didn't realize there was a platform IO plugin for it. So that's been around since the beginning almost?
About the beginning, yeah. It was enough to get the chip off the ground, but just barely. It used all the same Mound River EVT stuff. So Mound River is the proprietary sort of development kit environment for the CH32V003 and really the whole CH32V line. CH being WCH, the semiconductor in China.
Company. Yep.
Totally. Yeah, and V meaning RISC-V.
The V is V003, right? Yep.
Oh yeah. V, the RISC-V is CH32V. Yep.
Right. Yeah, and actually, so Dave, my co-host, has also done. I think you referred to your video, you referred to his video, but like the Mound River. Yeah, and it's just like a Eclipse-based IDE, right? It's nothing fancy. It looks kind of just standard style tooling.
No, the IDE is just fine. It's just a lot of it has to do with sort of the issue, I think, is that this entire space has sort of acquired a baggage surrounding it because of a lot of decisions that ST made about 10 years ago.
Oh.
And all the way down to, like, for instance, the minimum blink program for the CH32V003 is like, I think over a kilobyte. And it also has to do like software divide and multiply on boot up. Like, it's a bunch of, anytime you do pretty much anything with it, it brings in far more than you would hope that it should bring in.
That's like in the STM32F0 line. Where did that come from?
Oh, yeah. So in the STM32 world, they have sort of this HAL, they call it, the hardware abstraction layer, in order to abstract all of the hardware from most user programs, in order to facilitate people moving between processors in the STM32 family. And it kind of sort of worked-ish for them. It also had this interesting effect of sort of vendor lock-in, at least up until recently, because like, yes, you could be able to take your code and port it to something else if you were conscious about it. But if you're already using the entire SDK from ST Microelectronics, then it's a little bit harder to get out of that ecosystem. And it worked out like really well. And it also made it easier for some programmers to be able to hop in and like get started. It's just that it's still an abstraction. It still adds sophistication and complication and problems to the overall software development process.
Yeah, I think that, and it sounds like a mistake that's been many times in a lot of different platforms as well, not just there, just like the making it easier and making the support load easier for the company that are building these chips.
Yeah. And to an extent, that kind of makes sense. If somebody says, hey, I'm having trouble with my code, and it's like this gnarly, drawn out piece of very hard to follow C code, that's going to be hard to support as a company. But if they're already forced to use your HAL, your abstraction layer, then that gets a little bit easier of like, oh, well, you're doing this wrong. So you don't have to worry about some of the lower level things in that support burden. So I understand where those desires came from, but the tax is just so heavy that comes with it that it's just, for me, I've always kind of struggled to find some way out from underneath that load.
That's interesting. So, like, if you find a new part, say you found, let's just say vendor X, so there's some brand new vendor.
Hmm.
Are you more likely to throw away like a HAL that they provide and then go write your own?
I think it depends on what my goals are. If my goal is to use this part to accomplish a specific project, then no, I will absolutely use their HAL 100%. And I think it is crucial for programmers to understand these HALs and why they exist. And I think that for me, using those HALs sort of like keeps me up to date with that and keeps me my understanding of what they're trying to accomplish. Like, it makes that very clear to me.
Mm.
If my goal is much more sort of like, this seems like a gateway to a lot of projects and a lot of really interesting stuff that could be done, then yes, my goal would hopefully be to engineer a new sort of like minimal SDK surrounding it. But the
Hmm.
effort that it takes to build one of those SDKs, to go all the way back to the metal and just build something that's fast and
Right. Yeah.
simple for users to use, it's a couple months of investment. So I only do so very judiciously.
Yeah. That's a lot of cozying up to a data sheet on a Saturday night with a glass of wine, sort of thing, huh? A lot of register maps in your future.
Yes, there had been many nights in the last couple months where I'm sitting there on my cell phone paging through the technical reference manual in bed, making sure that like I'm not missing something. And it's like one of those things where it's like, this is really hard to do if a data sheet is 1,000 pages, but when a data sheet is only 300, 400 pages, it becomes tenable for one person to actually, and like for several people to actually understand like what makes this chip tick. And I
Mm,
think that that's a really interesting part too about the CH32V, is that it isn't 1,000 page technical reference manual. And it,
mm.
it it is something where you can sit down and over the course of a few weeks, you can really understand, maybe not like all of the details of every bit in every register, but you can understand how the chip kind of fits together and how you can leverage that in your own sort of engineering.
Yeah, that makes sense. Yeah, and I think especially like as you're saying, collaborating and not having to like compartmentalize. Like there's abstraction layers, but then there's also just compartmentalizing for as your team needs to grow. If you want to like have a faster timeline, then you start to grow how many people are a part of it, and then you start to
Mm,
compartmentalize and say like, well, I'll just do the ADC, but then you have to start agreeing on
yeah.
APIs and all that other stuff.
Yeah, a lot of people, I guess. So going back to it, when I mentioned, oh, if I need to just do this one specific thing, I'll just use whatever HAL is available. But also, if I have a team of like 30 people and it's going to be some really big effort, like they're 10 people, 5 people, about 5 people, I think, is where
Yeah.
this trade off happens.
Hmm.
That's when other environments like FreeRTOS and stuff like that start to actually make sense, even though they themselves are a massive tax to debugability and like
Sure. Right.
general like the number of
Lightweight.
times that I found where it's like we're like, okay, now we have the thing almost working, but we're having to like balance the size of each one of the stacks and trying to get like, oh, but it becomes so burdensome. But the answer is like, we wouldn't have been able to even get to where we were in the speed we
Right.
were able to unless we had like a framework that a lot of people could speak a common language into. It just
Yeah.
bothers me that the tax is so high. So when it comes to something that it's going to be me alone or me with a few other people going to be working on things, then I think there's a lot of value in just jettisoning a lot of that complexity.
Yeah, it also is interesting thinking about like how how far you would expect the chip to go. So like there's the complexity you've already kind of talked to, like
Mm.
just in like, sometimes they talk about like kilolines of code, but even yeah, I think actually datasheet pages is a good like kind of hardware firmware crossover one.
Yeah.
But then like how if it was like so I'm using this NRF 9160 a lot, and if it's like a dual core M33 plus cellular interface like craziness, right? It's like that's probably going to have more needs for outside libraries and like interface layers to like other third party plugin type things, and then like at that point, then it probably makes sense to have more stuff than you might want to try and do with it. It's kind of like how far are you going to try and take this thing, that sort of thing, like this specific part.
I think that comes down to two pieces. One is sort of like some of what you've described. Like if you were going to do something that requires significant and sophisticated integration with really advanced IP stacks, Like, okay, fine, you're going to use like FreeRTOS and lightweight IP or something.
Mm-hmm.
But also it comes down to the programmer. Like a lot of programmers who have lived in that world are really only comfortable in that world, and there are other programmers who have not lived in that world and can go much further on just sort of the bare metal. And it's, I don't know,
Right.
I would encourage, I would really encourage as many programmers as possible to sort of explore the bare metal arena to see how far they can push it, because you can go so far so fast, and you can produce products that don't have the sort of like the long tail of problems
Mm.
that sort of come with more sophisticated and deeper systems, where you're like, yeah, 1% of customers, 1 out of every 1,000 times they turn on the device, it doesn't turn on, and they have to like reboot it.
Right.
And you're like,
That's
okay,
bad.
well, great. That's like, how do you debug that? And a lot of that is a function of just how much complexity has been hidden away. Like when you
Right.
when you shovel complexity under the rug, it's still there. Like, it's not like the complexity goes away just because, like, oh, well, my application is only 40 lines of code and it does all of this cool stuff. Yeah, but like that's great. Like, you were able to do that quickly, but like at the end of the day, as you keep abstracting things up, like you acquire all of the burden and
Mm.
all of the technical debt of all of the pieces underneath of the whole umbrella.
See, now that's interesting because so we've been talking about RTOSs and like kind of the dangers of an RTOS, but that also, it sounds to me when you say like it's only 40 lines of code, that sounds like kind of more modern interpreted languages that people are pushing down onto micros as well. But they're like,
Mm-hmm.
yeah, it's only like, it's like one line to get a network connection. Is like, okay, sure.
Yeah, but I mean, there is a sort of trade-off there. If it is a
Sure. Yeah, yeah,
hobbyist,
yeah. Yeah.
like
Oh, no doubt.
there's a lot
This
of
is
value to
definitely
that.
ease of
Yeah,
use versus like longevity
yeah,
and security and
that's
everything
true.
else,
Yeah,
right? Yeah.
yeah.
Yeah, it's interesting. So you said, you're cozying up to the datasheet quite often.
Hmm.
Given your experience, I actually had a friend tell me recently, he's like, the thing I'm most scared about switching from ARM to RISC-V is actually just that I know the ARM instruction set pretty well, the Cortex
Mm,
M instruction set pretty well. Is it like reading a new language, or is it like
yes, I'm not going to sugarcoat it. I'm just not going to sugarcoat it.
right,
It
right?
is. I know ARM assembly pretty well. I know Extensa assembly better, and I
Uh-huh.
know x86 assembly better than that. And it has actually been a struggle because I guess I know AVR assembly the best,
Hmm.
and it has been a struggle with the RISC-V architecture because there are so many situations, and it sounds really nitpicky, but
That is what we're here for, CN. That's what we're here for.
but
This is what the amp hour. That's basically like a subtext of the amp hour. It's really nitpicky about electronics.
the funny part is, like, there are things which on every other sane architecture are just a single instruction. And in like the RISC-V world, that's just not the case. Like if you wanted to compare, like, there's no, like, as far as I know, maybe I'm misremembering, but I don't think that there's any sort of like compare this register against an immediate and jump if. There's no like flags for like an overflow flag or like a negative flag or something like that. All of these
Hmm.
things are it's very C centric instead of assembly centric, and it's
Mm,
very like, and I say assembly centric, it's still assembly, but it's like there is sort of like when you code things in assembly, there's some nice things to have
yeah.
that like aren't necessarily in C, or like that that RISC-V is kind of geared around like, no, we wanted to make a processor which is going to be like the reduced instruction set, and it's going to be able to compile from C to this very effectively. And they really accomplished it. But it means that when you're writing the assembly code for RISC-V, which inevitably you will always have some of, like
We're
it,
gonna get to that, I'm sure, with the USB stuff. I'm sure you were down in
yeah.
that in the depths. Yeah.
Well, I mean, it's not just that. It's a lot of places you find yourself writing assembly for
Mm,
a lot of things.
yeah.
But it's yeah, but yeah, I did spend a lot of time writing assembly for the USB thing. But at any rate, it is sort of like, okay, I have to actually do all of the actions at a very low level and very carefully, and
Mm,
it has taken me about as long to really learn RISC-V assembly as it has just about any other assembly.
okay.
It's not that it's like so close to some other one I was able to just jump to it. Maybe there is.
Yeah.
I guess like maybe MIPS it's probably very similar to, but I
Hmm.
never learned MIPS assembly, so it's been a bit annoying.
Mm. Yeah, no, that's an interesting take. I mean, like we've kind of described here, you are kind of in the depths of the data sheet and you're doing all this stuff anyways. So it sounds like it sounds like a good thing to learn anyways, and the switch over is kind of tough. So it's
Yeah.
good to know.
And I would say, like, no matter what architecture you're on, if you know the assembly, like, you're going to make better decisions when you're coding for
Yeah,
it. Like,
yeah.
if, for instance, if you're on Extensa, like Extensa, the ability to go load a 32-bit like immediate, like a 32-bit value and load it into a register or do something with it is actually really slow. But like that's not the case on RISC-V. On RISC-V, it's 2 instructions, but it's much slower on Extensa. And so sort of like the way that you will write your C code should be slightly changed in order to kind of think through how is this going to really be compiled on the system.
Yeah. I wonder, is there additional benefits to knowing the low level stuff? Because it doesn't seem like the extensive stuff is often, when we say extensive these days, I feel like, all right, we're talking about expressive, right? At
Yeah,
least
yeah,
the former
yeah,
wrote expressive.
yeah.
It's not like a lot of people are using extensive otherwise, though it does exist. And it's like, okay, so it's on expressive parts, but those things are beasts, right? I mean, like they are really beefy
Yeah.
processor. They're like 150 plus megahertz cores, and like, but they're not targeting it down at the low level stuff, whereas the RISC-V stuff is trying to play in that low end environment.
That is true. At the same token, the RISC-V stuff is just generic. It just happens to
Mm-hmm.
be that somebody is playing with it in the really like low end
Okay.
space. And like going back to that, even like it is funny because RISC-V in sort of the space of where the CH32V003 lives. Actually, let's just clarify. CH32V003 is a RISC-V processor. It's got 48 megahertz. It's got
I
16
was
kilobytes of flash, 2 kilobytes of RAM.
I was literally about to ask us to zoom out and ask about this. This is
Yeah.
perfect. Yeah. Okay.
So like it's basically an AT Mega 168 with more RAM. Like
Uh-huh.
that's basically what it is. It's a little bit faster. It's got
It's got 18 GPIOs. It's got UART, SPI, I squared C. I'm reading the TIMI
yeah.
page. SPI, I squared C, 8 channel, 10-bit ADCs, timers, 4 different types of packages.
Yep.
What else? Anything? Oh, yeah.
I mean, it's basically an AVR. And like I think that's
Yeah.
kind of what drew me to it is just that
Okay.
it really is this basic part. Except that it uses RISC-V, which is really nice for a few reasons. One is that like all of the existing compiler tooling is being done for you. You even get GDB, you get all of the
Mm,
extra like the sort of low level tools work, and they work really well because they've been tested across a wide variety of things versus like AVR GCC is like I'm trying to remember. There was actually like a product I was working on where we found out every now and then it like lost an input. And with this, it's hard to explain like why that's important, but like it
oops,
was
all
literally
berries.
just like X plus plus, and now X isn't right. And we dug into it. And it turns out there was a compiler bug where it literally couldn't reliably add a not like I equals I plus one on a 32-bit int. And it's like, how does that even happen for a
Right.
mature compiler? But like, I mean, I understand that it's just because the AVR GCC doesn't have as much mileage on it as some of the other compilers, but it's still
Yeah.
just woof.
It
Yeah.
is interesting too, because like it seems like you're still not still, you're in that interstitial space, where it sounds like you're kind of talking like a grumpy graybeard, right? Of like, I code assembly and I've dealt with tools that have this other stuff. And then, someone listening now, they're like, well, of course everything works. Of course you have all free tooling. Of course you have compilers that are reliable. Like, like that kind of like difference in perspective. Some of that is number of miles on you in terms of like how many projects you've done, but it's also kind of bridging the gap from
Mm.
the old microcontroller way into some of the new microcontroller ways. It feels like.
Yeah, I think that Espressif was a very good picture of that. That there was only going to be one of these in the history of all of computing. And what happened with Espressif was they used their Extensa core and they used the proprietary Cadence GCC. The Extensa GCC was not open source. It was well, I mean, it was kind of open source, but only half open source. And to use the ESP8266 core, that was not open source. You had to use the proprietary compiler. And it was only through the efforts of a handful of people out in the community who like took it and was like, this is an amazing chip. If this had an open source tool chain, it would be amazing. And they did it. And sort of like, I think the only reason Espressif opened up, and people might not remember that, originally Espressif was
Yeah, they
completely
didn't.
closed.
They didn't care at the beginning. They did turn, which is great. I mean, like
Right.
they recognized the power of it. They're like, oh wow, look at this community stuff. That's great. They definitely have invested in it a lot.
But they only turned after the community stepped up
Right,
and was
right,
like, this is so much more powerful than you guys realize.
right.
And people started exploring that space, and Espressif embraced it. So instead
Hmm.
of like trying to fight it and doing takedown notices off of like literally all of the early ESP8266 development was done
Hmm.
on this like leaked VM from some partner customer of Espressif.
Oh, really? Oh,
Those
interesting.
XP virtual machine that you run in VirtualBox, and it had a copy of like the compiler.
Sounds like there's gonna be a book about this someday, huh?
Maybe.
Yeah.
I mean, I hope that was it, because it was such a significant thing. Like people just don't. I guess like it was always the norm for all of the really interesting processors to be totally closed, and like AVRs were the exception. But that's not the case anymore. Now, more and more, the companies are starting to understand that, like, no,
Hmm.
actually, if we make it available to people first, it's gonna go better. And I think that like WCH also realized that, like, that was, I think,
Yeah.
part of their big effort was they really wanted to make sure that even if not 100% of it was open, at least it was usable by anybody, even on
Yeah.
their official Mound River SDK. And if it wasn't for Espressif having this fortune that they had, where like, because Espressif didn't resist it, because Espressif embraced it, Espressif grew. I don't know what their market cap was 15 years ago versus like today, but I'm pretty sure it's way bigger.
It's way bigger, yeah. I mean, they're listed on the Shanghai Exchange now, so
Yeah. And
yeah.
it's not because they had some magic silicon. The silicon was no more interesting than any of the Realtek silicon or any of the media. I guess MediaTek is bigger, but their silicon wasn't that interesting. It was just interesting that you could actually do something with it. Like,
Mhm.
you think about the single like one by one USB Wi-Fi dongles. Those existed at that time, but
Mhm.
nobody had sort of a way of which, oh, well, you can go code it and actually flip some GPIOs. And it was like,
Right.
it seems so silly that like literally all any of these other companies had to do was just, okay, make it so other people can flip your GPIOs. But I really think it all comes down to that one leaked VM. Like I really think we would be in a different world today if that VM had not leaked.
Doesn't cost play into it though? Too? I mean, like some of it is. I mean, I just much like we're talking about the CH32V003 as well. Like cost is a headlining feature in all of these spaces as well. It feels like. I feel like that can't be ignored. Like
Yes, that is absolutely true. And I think that, like, so if you look at the time, TI sort of had their, I forgot the name of the part, but their CC series,
CC24. Yeah.
yeah, that one.
Yeah.
And
26. Yeah.
it was functionally almost as good as the ESP8266. Like, if they had made the right play, it would have been the thing that hobbyists would have used. But there is sort of, you're right, that there is a sort of magic change that happens when the modules that you can go plug into your part is $5. You can get
Hmm.
Wi-Fi for $5. And in reality, like we people kept finding out ways of making that cheaper and cheaper. And so like by the end of it, it was like, okay, well, the reality of it is now it's a sub-dollar part that you can go include on your schematic, and now you have
Right.
Wi-Fi,
Right.
or the sub-dollar part is your microcontroller and your Wi-Fi. And
Right.
now it's just
Exactly.
like, if you have any reason to have any connectivity, you'd be crazy to do anything else.
Hmm.
And that is an interesting point, because like, so there were other companies who were playing in the space, that like the cheap Chinese or Taiwanese like chip market that had Wi-Fi at the time, but their stuff didn't leak, and so they weren't able to make it.
Right. Right.
And you had these other companies like TI who were playing in the space, but their stuff was really expensive comparatively.
Yeah. Right.
And sort of like, I guess you're right that it is a confluence. It was a matter of them being cheap, and it was a matter of them also like having the availability to do interesting things.
Yeah. Well, read my book in 24 months as I write about the history. No, I'm just kidding. I'm never writing a book like that. That would be terrible.
I am unfortunately not an author at all, so
Yeah.
somebody
Yeah.
else is gonna have to write that.
Yeah. Yeah, it's interesting. So we were talking a little bit before the show and about, specifically with the 8266, so a lot of it, when I look at the espresso stuff, I think the community-based growth is definitely when the Arduino port started happening. That really
Hmm.
opened up a lot of things as
Yeah.
well. But then that was layered on top of an RTOS, I believe, right?
Yes. Yeah. It was. Yeah. Yeah.
Yeah. And then, but then you started, so you have a YouTube channel, which people should go check out, of course. And you have some experiments on there where you're like, yeah, we don't need an RTOS. And you kind of alluded to that earlier too. So what did that look like in that space?
It was, well, okay. I guess the 8266 is interesting for there's a caveat here. Well, okay, let me say what I did and then I'll explain the caveat. So one of the things I did was I was like, well, the ESP8266 is really interesting and fast, but there were aspects of it that were kind of being burdened. So they called their original SDK the non-OS SDK, alluding to it being a pretty simple and Spartan development environment. It had timers and it had malloc, and that's really about it as far as their like OS environment goes.
uh,
And it was a really good thing to write stuff in. But and then on top of that is how they built their Wi-Fi stack and their IP stack on like LWIP and their proprietary Wi-Fi stack on top of that. And it worked out pretty well. It was not nearly as heavily burdened as FreeRTOS was on the part. So like later on, there was a community port of FreeRTOS to the ESP8266, and the non-OS SDK was a lot cleaner and booted much faster and more powerful. I would say, well, powerful depending on your definition of powerful, than the FreeRTOS stack, but eventually the company really decided like, no, we're going to go in the direction of the free RTOS. And so I was like, well, what happens if you just go the other direction, just kind of as like an experiment? And I was just curious, like, because like now all of a sudden you don't have any of the same restrictions surrounding like how the hardware should be used. You can just use it to do whatever you want. And so I called it no SDK 8266. And the answer was like, oh, you can actually just like get it to wake up, blink, do some basic stuff, use some of the basic IO. Like you could use the DMA on the I2S engine to send and receive like 80 megahertz bit streams and stuff like that with like a kilobyte worth of code, which also then opens it up to like, oh, well, now you can just run everything from RAM because now you don't have to have this huge amount of like space that is filled with all of the code to support the system. Oh, and you can also now flash it like in half a second. Like your compiling and flashing process is basically instant. When you get all of those pieces together, it is kind of this fun environment. And a couple people did take that and like do some other fun little projects with it. Oh, the one of the other parts about that makes it interesting is that when you're in that mode, you don't have to work at 80 or 160 megahertz. You can just take the part up to around 380 megahertz and it works just fine.
wow.
Like if you're not limited by the same like sort of like assumptions, because like they made sure that all of everything surrounded the Wi-Fi chip. And the way the part is configured, you really can't use the part at anything other than 80 or 120 and still use the Wi-Fi effectively. But like if you're not using the Wi-Fi, which no SDK 8266 didn't do, that's the caveat. When I wrote this non-OS stack, it
Yeah,
didn't have
right,
Wi-Fi,
right.
but it is a pretty interesting microcontroller at that point anyway,
Yeah.
and it goes crazy fast. And yeah, so it was a fun, interesting experiment. Ultimately, it was never really adopted by any major projects or anything like that. And I didn't really
Mm.
expect it to be. It was such a strange thing to take this part that people are like trying to now like go more in the direction of free RTOS with,
Yeah, yeah.
and then be like, well, what happens if we just tear it all out? And the
It's
answer was it was a fun,
contrarian. Yeah.
yeah, contrarian. It was just an experiment, and it
Yeah.
was fun, but there really wasn't that much that was that interesting about it, I think.
Okay. It's interesting. So that is usually the point that I have a marker in the sand that says when there's a networking stack, when there's stuff that's going to be like internet based, I think it's into RTOS land. Is that a fair characterization from your perspective, or do you put that marker in a different spot, given our conversation here?
I don't I don't. Well, there's really two parts. One is like I acknowledge that is usually where the marker is, but
Okay.
I acknowledge that only begrudgingly. In that, like I have done things with like IP stacks. One of the videos I did was Minecraft on a microscope slide, where I literally
Okay.
made a circuit board on a clear glass microscope slide that had an AVR and a ENC424J600, which is an Ethernet adapter or Ethernet MAC and PHY.
Ah, yeah.
And I ran Minecraft on it, and a whole Minecraft server, multiplayer Minecraft server with, I think it supported up to 8 players, and it had an SD card to store the chunks on. And all of
Mhm.
that was on this little ATmega 168. Oh no, it was 328, ATmega 328. So it's got like 32 kilobytes of flash, about 2 kilobytes of RAM. And it had no problem doing this. And it could also like serve web pages and stuff like that while it was working. So like there's nothing that stops you from using.
Sure. Okay. Yeah. These are rules of thumb that are probably not applying to CNLohr. Is that a
Well,
fair?
it's not just me. Like there are a lot of other people who sort of play in this space. Like
Yeah.
I was definitely not the first one either. Like I can't remember his. I know he goes by Igor online. Igor Plug was one of the projects he did, where he did a similar thing where it was just like you say, I bit banged on, like you mentioned, I bit banged on the AT Tiny 85 at some point. Like, yeah, I did do bit bang,
Yeah.
but as soon as that article hit Hackaday, everybody was like, hey, 10 years ago this other guy did it, and Hackaday published the article about it, and it was like I had no
Wait a second.
idea.
People in a Hackaday comment section pointed out as something being done before. That's so odd.
I mean, it was kind of embarrassing that like I had not
No, come
not
on.
actually done the prior work and realized that, or like checked for it and be like, yeah, no, somebody had already done this like 10 years ago. And so it's kind of a thing that's been done a fair bit. I I've also sort of in working for other people, like I've seen a lot of custom TCP/IP stacks out there. Like lightweight IP is not the only game in town. And
Sure.
I think a
Sure.
lot of people forget that, and that there's a lot of other trade-offs that can be made. You're not limited to that. And the same thing goes for things like lightweight USB, which is a total misnomer. Lightweight USB is massive.
Hmm.
It's a huge USB stack. I don't really know why it's even called lightweight. Maybe it started off as lightweight, but like there are lots of other options out there, and a lot of times like I think engineers are scared of, or project managers are scared of, like, oh no, it's just USB, we can just write that, or oh no, it's just Ethernet, like it's okay, we can do that, like you don't need
Hmm.
all of these crazy stacks. So like I don't want the flag to be at, when you're using IP, well now you're using free RTOS, because
Hmm.
like I've seen times where that's not true, and I don't want, I wish engineers were not limited to that thinking, cuz I
Interesting. Okay, let me put on my project manager hat here then. So like what do you say to a project manager who's like, well, what about support burden? Because I feel like support burden is the main reason in my head that I think like don't write that from scratch. Is that fair or unfair?
I think the problem here is that I don't think I would win an argument in this. Because I have been around the block, and my experience says that no, there is a massive amount of support burden with free RTOS.
Totally. Yeah,
I'm
I
picking
think
on free
that's
RTOS, but that's
no,
only
no, no. That's
because
fine.
that's where I'd have it. And it's not because free RTOS is bad. It's not
Yeah.
because there's some bug in it. It's because of the type of code that people who are using free RTOS write
Hmm.
inherently. Like free RTOS is great if you have like one thread, but the reason you're using free RTOS is because you have
That's
a
yeah.
lot of threads.
That's right. Yeah. Yeah.
And when you start doing that, you start finding these really rough situations that you run into, because the burden of pushing and popping things off of queues inside of interrupts instead of just doing the work in the interrupt is so high that you end up like burning a lot of your
Mm.
CPU. And even though you started with 144 megahertz or something, like it's just, well, now you've burned it all. And I
Mm.
think one of the problems is if you put on the business hat, you're like, well, we'll just buy the next more expensive processor and just solve it by putting in a more expensive
Right.
processor,
Right.
which,
Right. We have the margin. We can eat it. That
yeah,
sort of thing.
that
Yeah.
bothers me a lot, because if you multiply it out, if you're making a million of something and now you're spending 30 cents more per thing,
Mm.
that's $300,000. Whereas if you just made a different decision up front to be a little bit more dainty with your resources, then you wouldn't be in this position.
Hmm.
So it's
No,
something.
it's interesting. It's interesting take for sure. And I think about it with the, like, so I've been working in the Zephyr ecosystem, and like in my head, at least when I think about these arguments, it's like, well, who's someone else is maintaining that, it's like there's a bug fix, there's a critical, there's like a heartbleed style thing where something has to be updated. Now your internal company that is hasn't developed the stack, someone else has developed it, and you're pulling it in, or the community is pulling it in. Like, then you get that benefit, right? You get that kind of network effect from an ecosystem of an RTOS.
Mm,
But
yeah,
that's non-zero time as well, because moving up to the next version, so
right.
it might be equivalent in a best case scenario as well.
Yeah, it is a tough one to sort of articulate around and like
Hmm.
really think through. I don't think that it's 100% clear win,
Hmm.
because if you think about the attack surface of a lot of these other things, you end up bringing in far more features and far more lines of code that are far more like, each one of those lines of code are more susceptible
Hmm.
because there's so many of, or sorry, not each one. Each one of the lines of code is the same level of susceptibility. And like, yes, it's going to be fewer holes per line of code, but they're still going to be there. They still get discovered. They still like, it's shocking how far things can go before bugs are found that may or may not have been introduced in a base, like if you were to do it yourself. Like, there was a stack that I used for a commercial job I did a long time ago, which was, this is literally certified for aircraft. The stack was certified for use on aircraft, and we couldn't figure out why, where about one out of every 65,000 packets we sent through, it didn't go through, and we could resend it and it would
Suspicious.
never go through. And it's like, but like the last place we thought to look was inside of this stack, and no, it turned out that they had missed one of the rules surrounding UDP checksum. So like, even though that was really mature and it was really sort of like, it was in a world where it's like, this is clearly a commercial product that was made by experts, there's still bugs, there's still
Yeah, yeah,
holes.
totally. Yep.
And like,
Right, and you had the burden of finding that too. It wasn't like
yeah,
there was an announcement that came down. You also found it, so then you also had to push it back up and say,
yes,
"You guys go
yes.
fix this," and then it comes back down. You have to like implement the
Yeah.
fix.
Yeah. So it's like, those sorts of things, like, they shouldn't happen. But so like,
But they do.
if you reason about like sort of the rationality surrounding why you would always want to use lightweight IP, or always want to use one of these commercial IP stacks, or always want to leverage this. It's like, in the nominal case, that is 100% true and it's irrefutable. But in the like actual boots on the ground case, it's like, I think I would still use them like 90% of the time. Like, if I had to go do something for a commercial job, I would still just use lightweight IP. I guess that's not always true, but more so than not. But if there
Mhm.
were situations where that might not make as much sense, or it might be a more constrained system or something like that, it, I mean, like, full disclosure, I did actually use that Minecraft stack the IP stack that I wrote for the Minecraft thing in a commercial project once. Like,
Yeah. Okay. Yeah.
like it,
Yeah.
it made sense. Like, I had it and it was the right solution in that situation. And so I
Yeah.
used it,
Yeah.
and it worked fine as far as I'm aware of. Like, I've been in contact with that customer for a while and have had no complaints. So, I mean, maybe I just got really lucky. I don't know, but it's very strange to reason about, because the nominal case is 100% always you should be using like the extra like free RTOS stack, or any of the RTOS stacks, and like an established set of libraries for all of the stuff. But in
Mm.
reality, it's, I guess, it feels a little bit less clear.
I kind of think about it like there's like a lot of pushback about, not a lot of pushback, but there's like people like, oh, you don't need a college degree. You can prove out your, and this is me saying this too, right? It's like, I've met a lot of very interesting people that could prove their abilities, and they've learned on their own, and they could prove it through like projects and their past work, and like a college degree does not bestow that. But like in the general broad case, it's still like companies are like, yeah, but it's a pretty good indicator that I could hire someone
Yeah,
to teach them. It kind of feels like the same thing, where it's like this kind of general use case. It's probably, it's a general rule of thumb, like, yeah, use this thing, but there's going to be corner cases always, and this sounds like
yeah.
that might be one of them.
That's a really, really good description of it. Like, I have never heard anybody make that comparison, but I really like that a lot. That's because it really is like the college degree. It is a piece of paper. There's somebody who went and did a bunch of unit tests, and yeah, their unit
Yeah,
test
right.
probably didn't test your one specific situation, but it does give you a pretty good baseline of expectation for the
Yeah,
competency of that
yeah,
tool.
yeah.
And that's a really good expression of it. And I've worked with people who are absolutely stellar without college degrees, but in general, if you don't really know,
It's
it's
hard to hire it that way, right? You think like
yeah,
you're at Microsoft and you're like, all right, we got to hire 2,000 engineers this time. It's like, how many project portfolio sites are you going through? Like, that's a little tougher, you know?
that's a really, really good metaphor. I really like that.
Thanks. That's nice of you to say. I just thought of it. I would. So okay, let's talk about now. Let's talk about a corner case because there's interesting corner cases that you've been working on specific to the
Hmm.
CH32V003, and I'm getting better at saying that part number thanks to you. Let's talk about USB. So you have implemented USB stuff. I'm not sure the full extent of the USB. I'm just following your Twitter account, and it's in the bootloader.
Hmm.
So what's going on with that?
So a couple pieces here. One is I have already kind of coded my own USB stacks in the past for a variety of things. So I do have like a background in USB, and it's something
Okay.
that like I always kind of like side eye. I'm like looking at it and I'm like, can I somehow work this in?
Yeah.
And
Quick question about that. Sorry,
oh go,
sorry to
oh
cut you
go.
off. The hardware that you have for so one thing that's always scared me about USB is like I don't have any protocol decoder or anything like that. I know like the Beagle's a
Mm,
big one. I have a Luna on order. With all apologies to Great Scott Gadgets, I've had a Luna on order for 18 months, and it is languishing, and I can't figure out how to cancel my order.
mm.
And so that's been one of the big scary things for me. I assume you have. Do you have hardware on hand for decoding?
Yes, I absolutely
You
do.
do.
I will
Okay.
say I don't think I would have been able to, because like if I don't know if anybody out there is familiar with VUSB, but somebody had actually coded a AVR software only USB
Mm.
stack for USB low speed. And I don't know how they did it. Like I literally do not know, because they did it in an age where there weren't cheap,
Like
easy to
affordable.
access,
Yeah.
yeah, USB things. Now we're
Yeah.
at the point where
Never
like
discount someone bringing a tool home from work though. Too.
I that's a decent point. Yeah, if somebody
Yeah.
had, but it is extremely difficult to code a protocol like USB without some sort of protocol decoder of some sort, and
Yeah.
like being able to get all the timing to match up and all of that. It's very hard. But when you have all of those tools so that you can go like write some code, fire it up, see what it
Yep.
looks like, see
Yep.
how this worked, and then just keep iterating.
Yeah. Step, 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 step. Oh, there's the error, right? And then it's
Yeah,
like it's
yeah.
basically like a yeah, it's a debugger basically in the physical realm.
Yeah, like if you have all of that, and I do. So like on my live stream, I actually so I did all of the development of the base USB stack live on YouTube.
Wow. Wow.
But like it worked. Don't get me wrong, it worked out to like 5 live streams, each like 7 hours a piece. Like it.
I'm just really impressed with people that can do live streams because I cannot concentrate. I'm like so like worried. I'm always like looking at the camera. I'm like, oh, people are watching right now, and I get like so anxious. Like I'm very impressed with people who can do that.
I I
Do you ignore the camera? I don't. I didn't watch
I
it. Obviously,
don't
sorry about that. But
ignore the camera, but I guess it's there's so it's kind of two piece. One is like, yeah, you spend more time like thinking out loud and talking to people, but that also
yeah,
means that there are rubber duckies. So if you say something
yeah,
stupid,
true,
you're like,
true.
oh wait, no, that's not right. Let me go fix it.
Uh huh.
And better than that, there's actually somebody on my Discord server named Duck who is rubber duckies who would like be like watching over as you're coding. They're like, hey, no, line 49, fix line 49. And it's stuff that
Yeah,
like
it's like
I would
pairing
spend,
almost, huh?
yeah,
Yeah.
yeah, exactly. So there's both a multiplier and a distractor from it, but like I think overall it's about neutral. It's way more stressful, I'll tell you that, but
Okay. Yeah.
it's as far as like actual getting stuff done is concerned, it's probably not a strict loss. So the idea though, I guess backing up, so I had done my own USB stacks. I had actually done ESP USB, which was USB on the ESP8266, where I bit banged the USB on it. So like the idea is it runs at 160 megahertz, and then I every 53.333 cycles, don't worry about how that works. You go either write or read a bit on the USB bus, and you implement the USB bus protocol. And that just worked. So I was able to go make a low speed device on the ESP8266 with it. I've done a
Mm,
lot of USB devices. Like I first started learning on VUSB for the AVRs. I'd also done a couple USB stacks for the STM32F042 and the ATmega 328 U4 and U8, or ATmega 32 U4 and 32 U8. And sort of like I was just ready to go with this because this is a 10-cent chip.
yeah,
And I want to be able to say, plug a potentiometer into it and get a joystick out of it. Or I
yeah,
want a mouse jiggler, or I want to something like, I want to be able to take input from the real world and control something in electronics. Or I want to be able to, from software on my computer, send messages to this device to go control some I2C thing, or magnetometer, or accelerometer gyro thing, or you name it, like any of this weird interconnection. Normally, you need something which is a minimum of an STM32F042 at 70 cents, or I guess that's what, 80 cents now? And then, or an ATmega 32U4, which is a very favored processor of a lot of people to use, but it's kind of slow, and it's also like $1.40, so it's like not
oh wow,
that cheap.
yeah,
But for this, it's like, no, this is a 10-cent processor. This is 10 cents. You have
yeah,
no excuse for just putting into something. So I want to be able to control these things. I want to be able to do all this stuff. And by the way, it's not just 16 kilobytes of flash. It's 16 kilobytes of flash plus this 1920 byte
mm,
special boot area. And so like the gauntlet was on. It's like, okay, if I can turn this into an Arduino where I can flash the part over USB so I don't need a programmer, then like that's interesting to me.
yeah, yeah, totally. You know, another interesting thing that's about this too is like every thing that you add, you I'm going to say you CN, but also like the community, like that encourages cloning. like like other manufacturers might look at that and be like, "Oh, we can make a part like that," or that encourages more parts like this. Like it's this weird like not network effect, but like this weird groundswell that might
Yeah.
drive other low cost parts and like other people implementing it. It actually could have an influence on the market.
I really hope it does.
Yeah.
And on top of that, like there's always the situation with providers where like manufacturers and chips and stuff like that. So if you have a product and you have vendor A and vendor B, you might 100% know you're going with vendor A.
Yeah.
Like you might know that like vendor A is it. This is like, we have to use them. But that doesn't mean you shouldn't like the thing you're looking for shouldn't be in the last place you look, because if you look at vendor B and you start talking to vendor B and vendor B can do it for 10 cents on a dollar that A can, well, now you can go back to vendor A and be like, look, I know you guys are better,
Right.
but
Right.
these guys are making a really compelling case here. This is 10 cents. This isn't a
right.
dollar 40. Can we
right.
do a little bit better? And
Yeah.
I sort of see some of this is doing that at sort of a macro level instead of a
Yeah.
micro level. And I really hope that that happens. You're right. I do think that this could be a sort of groundswell. I do think that like with ever since sort of like the Paduks started to dig into the space. Paduk is
Yeah.
an
The
8-bit
3 cent micro.
3 cent well really the good ones are like 6 cents, but
Oh, okay. Okay.
5 or 6 cent micro. I think that that kind of started to make people like, yeah, actually, yeah, we could probably do this. We could probably make these these things interesting in that space, and they did. And I think that I hope we can look back in 10 years and be like, WCH hit it. Like
Yeah.
before, they were really only known for being like cheap USB to serial adapters that you'd go plug up next to your Espressif chip. Like I hope that we can look
I do
back in 10
remember
years.
my first experience with WCH chips were like, oh, I'm not going to download that Windows driver from that random
Yeah.
ass site. And just like because they were going on like cheap Arduinos, I think, and I think that was
Yeah.
my first thing. And I was like, WCH, is CH in there? Are they Swiss? Like I don't know why I thought that was
Mm.
Swiss. Is CH something Swiss? I don't
I
know.
think so. Yeah.
Yeah, yeah. I just thought it was Swiss for some reason, and then I'm like, no, this is shady
Mm-mm.
looking site. But yeah, they're growing for sure.
Yeah, and I really hope that we can look back and sort of see. I really hope that they get rewarded in the
Yeah.
grand scheme of things for
Right,
sort of
right.
taking the risks and taking the stance that they have. Like there's no reason. I mean, other than I guess Poya trying to be poised for the space, I think I just feel like there's no reason for WCH to have done what they've done, and I just really hope that they're rewarded for it.
Yeah. Yeah, I mean, we're basically a commercial for like market systems at work right now. We're like capitalism, oh, reward the winners. But yeah, I mean that, yeah, sure.
Going back,
Yeah.
I guess just to finish the USB discussion. So idea was get this USB stack up and running, and the idea is like it's an interrupt that gets fired when the host sends a message to the device, and you just look at each one of the bits, each one. It's 1.5 megabaud for USB low speed, and
Mhm.
so every 0.66 microseconds later, you do another check, you do another check, you do another check, and you go read a message, and then I do all that in assembly, and then I kick the message out to C, and then I process the USB packet in C, and then I go
Mhm.
send a response back to the host in assembly.
Hmm.
This has kind of been done before with Granium, but Granium, there was a lot of compromises. Like Granium never checked CRCs. They just assumed everything was fine. Granium never,
Ah,
I'm trying to remember what was some of the other things that they did that was just rough. Like it was never the right answer. It was just sort of like theirs was an experiment to see what is the minimum possible thing you can do and get a USB device to enumerate. And Granium is for 48 megahertz ARM zeros, like the really tiny micros that have no USB PHY, but they're really cheap. And so for me, it was like, no, my flag in the sand, like the thing I'm going for is it's going to compute the polynomial for the CRC in line while it's receiving the messages.
oh
It's
wow.
going to compute all of the stuff surrounding like the packet type and stuff like that, like as it's going. It's going to do all of these things like as it's going, so that like there's this funny thing that happens with things like Lufa and Tiny USB, where when they get a message that says, "Hey, the host says it wants data," their first response is always to knack it and say like, "Nope, I don't have the data ready." Then they'll go and
Mm.
they'll have a user space, like let the user code figure out what to put there, and they'll be like, "Okay, I'm ready. Here's your data." And so I was like, "No, I don't want to do that. I want to just when the host says, 'Give me the data,' I want to have the data for it." And so I sort of like made sure that from the get go, all of those pieces were already designed into the low end stack.
Mm. Interesting.
And also like having to do things like retiming, which is where you like when the USB packet is sent from the host, well, maybe the processor was doing something that was time critical in that time, and now we started in the middle of a USB preamble and like having to resync ourselves to it. So all of those aspects, making sure that I handled all of that. So my goal is make a really robust USB low speed stack that can run on the device, and then build the other part on top of it. And so the idea is for the normal stack, what I want to do is just make it so it's not space constrained, and so you can have whatever features you really want. And it is low speed, so you can't be like a USB MIDI device or something like that, but you can be a
Hmm.
lot of
Yeah.
fairly interesting things. And HID devices are way more interesting, I think people give them credit for, because on Windows and Linux and all platforms that I'm aware of,
Yeah.
you
They
can just
standardized.
as a
Yeah.
user space application be like, hey, open this HID device. Oh, send this message. And it's not like, so with like serial and serial protocols, you have to have like framing where you're like, well, this is the start byte, this is the end byte, this is how I know how big it is. USB provides all of that for you. And the idea would be just make it so that the baseline is a USB PHY, so that's the assembly file, and then all of the rest of the stack that gets built on top of it can have a variety of different uses and could be like keyboards, joysticks, just generic whatever other input devices or egress devices. And yeah, sorry, I think that kind of covers
That's great. No,
the
that's great.
bigger picture. Yeah.
What about in the physical realm? Because like so, USB is differential, correct?
Yes.
Do you have to do something external, and then like how do you configure the GPIOs that you're going into? Because like most USB has specialized transceivers and then
Mm-hmm.
actual like hard silicon that processes and buffers that the frames, right?
Mm-hmm.
So what do you have to do then to modify the external piece?
Nothing.
Okay.
Oh, no, not nothing. You do have
Okay.
to have a 1.5 kilo ohm pull up resistor on D minus, but other than that,
That's it.
nothing.
Okay. Wow. Okay.
The nice thing about USB low speed is that it's only 1.5 megabit. And if you want to be able to send a differential signal, well, you just can turn on, like flip the state of the bits when you want to flip the state of the bits. And
Yeah.
It's just really, really simple stuff. So
Yeah.
it just kind
So
of works out.
by default, is it like, so the pins are set as inputs, and then as part of the processing, so like you're always waiting to receive a packet, whatever,
Hmm.
and then when you receive something, you do the CRC checking that you're saying in line, and then
Hmm.
you turn around and start sending something back. Is
Yes.
that at the same time then you're also turning those into outputs
Yep.
and then
Absolutely.
driving?
Yep.
Yeah.
Yep.
Okay.
So just switch it around, be output, and then start
Hmm.
sending the same sort of looking thing back at the host. And just using regular GPIOs is more than
Yeah.
sufficient.
See, I think that's the thing. Like, I have avoided it so hard for so long that I have no knowledge of what even is really happening there. I'm just like, well, make sure the lines are, controlled impedance, and, run up, make sure the part has D plus D minus. And you're like, yeah, then I hook A to B, and that usually always works.
Mhm.
But because I'm never digging down into the stack like you're doing, that I don't really have any knowledge of how to do that stuff.
It's a lot less scary than you think it is. I think a lot of
That's
people
great.
make
Yeah.
it really scary. Like when you look
Yeah.
at the USB standard, it's like 340 pages for the base spec, but that doesn't even really cover like HID, which is like another, I don't even know, huge amount of, like, it's like a book just for HID on top of USB. It's scary, but there's websites that really try to like actually show like, no, this stuff isn't rocket science. Like there's this thing called USB in a nutshell, which is somebody's effort to just, this is everything you need to know about USB if you want to implement it from the ground up in like in silicon or in code or whatever. And they succeeded. It's like, it's something
Yeah.
you
Yeah.
can read in like 2 hours, and now you can just know how to do USB. Like it's kind of surprising.
I think starting from that idea of like, well, like that mindset, like we were talking about earlier, of like that you can implement these things, and sometimes you should implement these things. Again, I'm never starting from that, and I think that you promoting that as a good, I think from a learning perspective, then, and also from a practical, like you can enable interesting things. This is a
Mhm.
really really good example of that.
Yeah, I think actually going back to projects with this. So USB wasn't the only thing. The first thing I did with this was the CH32V was make a Nixie tube controller.
Yes, that's what caught my eye. Yes.
Yeah, so the Nixie tube controller was a really interesting example of it because anybody in their right mind, if you need a 200-volt supply, well, you're going to use some specialized chip to do it, or you're going to use a voltage double chain with like a hex inverter, or like something like
Or
that.
you're going to use a part that you don't mind blowing up, so it should only be 10 cents.
Yeah, well, okay. But the sort of question for me was like, well, wait a minute, I already have a CH32V here. Can it just be the switch mode controller? And the answer is like, yeah, absolutely. There's no reason it shouldn't be a
Yeah.
switch mode
Yeah.
controller. And it's kind of funny that like we always think about it from like an engineering design standpoint of like, oh, well, if I need an X, then I'll go buy an X and put it in. If I need a Y, I'll
Yeah.
buy a Y and put it in. But the answer is like, you just don't need it. Like you can just code that sort of stuff directly into the processor, and
Well,
it's surprisingly okay.
you can code it in. I just say it'd be a little longer for me. Like, yes, given enough time and YouTube videos, I could do it.
But I
Maybe.
mean, if you think about it from like go to first principles of a switch mode, I mean, no, just okay. I'll go for it right
I
now.
never go there, CN. Okay, let's do it.
Okay, you want to be able to make like, let's just instead say we're doing a buck. So
Sure. Sure.
you have a P channel, you have your 3.3 volt rail, and you want to be able to make a signal on the output like half the voltage or something. I don't know what you're going for.
Sure.
So you
Sure.
have a PFET and an inductor. You just look up a schematic of like a buck converter, and it's like everyone's going to just show you this is how it's done with a FET. And so like now I want to be able to control that. Well, how do you control that? Well, you just use a PWM. Well, how do you use a PWM? Well, I have an example. Not me. It was somebody else who's written it. Several people have come together and written a mountain of examples. I think we're up to like
Yeah.
35 examples of
Wow.
like how to
Nice.
use the CH32V003 and other hardware surrounding it. Everything from how does it become like a I2C slave to an I2C master to SPI DMA. Oh, by the way, that's the other thing. It has DMA like for 10 cents. Like what the
Oh,
heck?
that's pretty great. Yeah. Yeah.
And the idea is, so you want to be able to control this. So you have a PWM, and you need some way of looking at the voltage on the output. Well, we also have an ADC. And so the idea is like, well, we'll just run the ADC. And if the voltage is too high, Well, we decrease the PWM, and if the voltage is too low, we increase the PWM. Oh wait, that actually just blew the thing up. It like locked up high. Oh, it's because we got the PWM backwards. Okay, so like, well, let's go flip the PWM around. Okay, well
Okay.
now it works. Like it's surprising.
It bucking works, right?
It's one of those things where it's like, this shouldn't work. This shouldn't work. This seems really hard. But then when you just do it, I don't know. I guess I've just been surprised by the number of times things have like, yeah, like the first time you do it, it never works. The second time you do it, okay, maybe it'll work somewhat. But like after you get through, like if you, I don't know, I probably for that Nixie 2 project, I had to compile the project 500 times. But like that sounds crazy. Like, oh, I had to do 500 times like iterations to make this work. But like when it takes you less than a second to compile and build and, flush out the
Right.
project, that's like, I don't know, how long did I spend on it? What's 500 seconds worth of time? Like
Yeah.
it's just
Right.
silly. Like
Yeah.
you can just, I don't know how to explain, like just if you
You're
break things
saying
down to
it
first
feels like it
principles.
really enables you. You
Yeah.
feel that this is a multi-tool
Yeah.
to end multi-tools of sorts,
Yeah.
right? It's
Yeah.
yeah.
And it's one of those things where it's like, in a way that before, I don't think there is very many things that would have made a lot of sense there.
Yeah.
Like for instance, like you need an IO expander. Well, yeah, it's going to take you a couple minutes to go write a GPIO expander, like slave
Yeah.
thing
I
for
squared
this for I
C
squared
to
C. Yeah.
8 pins, right? Yeah. Yep.
But oh, by the way, actually, I think somebody else has already written one. I don't remember what the repo is for it,
Yeah.
but like I think it already exists. But like you have that now, and so now it's like instead of spending 70 cents for the IO expander, it's 10 cents.
Oh
So
man.
like,
That's cheap, I think. I have seen some of those TI ones, they're real expensive. Oh
well,
man.
yeah,
Yeah.
no,
Yeah.
I don't know if I would ever buy one of them. They're
Yeah.
too rich
Right.
for
Right.
my blood. But
Yeah. So now this is an
yeah,
interesting, like this sets us up into an interesting space because the first thing that I think when you start talking about this is like, yeah, I could put this in, screw you chip shortages. I don't need your TI switch mode power supply thingies. I can do it myself. And then my brain goes, "Oh, wait a second. What if I can't get these parts though?" It's like
that's
always
a
this like,
really scary question.
yeah, yeah.
But
I live in fear. Given the past 3 years, I live in fear of all things shortages. But
I mean, I would say I've gone through this mental gymnastics myself, and I would say the chances of this becoming unavailable, which by the way, I don't think we're really in the chip shortage anymore. In general, most things are available now.
no, well, we've totally exited. We have exited.
But even when it was, like, would you rather have to get 30 different chips from 30 different
Ah,
suppliers,
that's an
right,
interesting
in
point.
order for
Yeah,
your product to be
yeah,
done?
yeah,
Or would you rather just get one chip from one supplier?
yeah.
And
Well, yeah, and low cost too. Yeah,
yeah,
and
well, it's
like
not,
probably lower cost
yeah,
than a lot of the silicon that's out there.
that's
Right.
true. But sort of like the risk is, it's like, I don't know how to articulate this, being on a product where I had to like sort of, I was never responsible directly for actually getting the stuff, thankfully, but like being aware of and trying to be like, okay, well, if we can't get this one random switch mode thing, like I
Yeah.
have been on LCSC before and going like literally just go to like DC converters and clicking on every single data sheet down the list, just like
Yep.
click, click,
Yep.
click, 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 click,
Yep.
click,
Yep.
click, 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 and
100
then
tabs open. Yep.
finding, okay, well, which one has the same footprint? Is there any way we can use, this chip instead
Yeah.
of the chip
Yeah.
that is now 52 weeks
Right.
out?
Right. Which
Uh,
which insanity should we really choose here? Right. Because they're just different flavors. Right.
exactly. Yeah. So it's,
Yeah. Yeah.
it's like, yes, it's a risk, I mean, WCH has been around for, I don't even know, like 10 plus years. So they're
Yeah.
probably not going to go anywhere. But even if they do, like, it's, they're all risks. Yeah.
The
Go,
only
go.
way to really do it is to build our own fab and design our own silicon. No
That
risk
is,
there.
yeah.
Oh
I mean, there
man.
are some people in my Discord server who I think are right
I
there,
believe
but
it. I
that's not
believe it.
me.
Yeah.
That's not
Yeah.
me.
Matt Venn is servicing that crowd with the with
Yes.
his online course.
Ah.
Yeah, that's great. So we were on the Nixie tube thing. So
Mhm.
what is the output? So you built a 200-volt supply using a boost, I assume.
Well,
Yep.
flyback.
Flyback. Oh, flyback.
Yeah,
Right.
yeah.
Yep.
The fun thing there is, turns out I was just browsing LCSC one day, which I just do. It's like, I don't know, some guys browse Home Depot, I browse LCSC, and I
Yeah.
came across this bizarre 10-to-1 transformer that in a 2.5
Yeah.
by
Yeah.
3.2 millimeter package, and just like, what in the world is this thing for? And at some point, it's like, Nixie tubes. And so I
Yeah.
started talking to this guy Spirit on my Discord server, who I knew had like some experience with it, and it was like it's like, oh, this is actually tractable. This is actually doable. And so,
Mhm.
yeah, like literally the entire high voltage circuit is a CH32V003 using one of its GPIOs for feedback and one of its GPIOs for controlling a MOSFET. No MOSFET driver. Forget that. We just have it going straight into a MOSFET.
Really? Oh, wow. It's got enough drive current.
Oh, plenty. It's got 50 milliamps
Yeah.
of drive current.
50. Oh, wow.
Yeah,
Okay. Yeah.
it's pretty intense.
Yeah.
And the MOSFET, I do have a MOSFET because I don't want to, I'm not completely insane. And then you just the idea is you use one leg of the transformer and pretend it's an inductor. So you like clamp it to ground, the other side is hooked up to 5 volts, charges up, and then you let go of that one side and it flips up. And then
Flies back.
the second side now
Yeah.
has 10 times that voltage on it. So you just go dump that through a diode into a capacitor. And that's it. And the idea
And
is you
you
just
do opto? Because I know like flybacks sometimes have optos
absolutely
to
no opto.
no opto.
Because we don't need
YOLO.
isolation. I'm not using the flyback for isolation because I
Yeah.
still like the idea is like I still need to turn on and off all of the cathodes on the
Oh, right.
on
Yeah.
the tube. So there's no benefit from having any of the isolation. I
Mhm.
only have the transformer here as a mechanism of getting higher voltage. So it's like that's it. It's just the CH32V, a MOSFET, and then the weird funky 30-cent transformer, a diode, and a capacitor. And that's
Do you do a divider though to get that voltage back down with the
oh yeah,
200
I
to
guess that
monitor?
is fair. I do
Yeah.
actually have a
That's the thing I was
divider.
really that's what I was asking about is the divider.
Yeah.
It's usually opto or divider or opto
That's
plus
true.
divider, right?
Yeah.
Yeah.
Okay, that's
Okay,
fair.
that's pretty
Although
cool. I mean, like, that's awesome. And then the rest of the part though is controlling the rest of the tubes,
yes, yeah,
the other
and
parts of the tube. Yeah.
yeah, and it kind of handles like some of the fading between the segments and stuff like because you can't have multiple segments on at once. You have to like actually like chop it,
Yeah.
and
Uh-huh.
it also is kind of the protocol engine so that you can go like command the tubes to do something, and it handles taking on that command and doing the right thing.
Mm. So what can't we do with this part, or really any? I mean, we're talking about this part, but we're really saying microcontrollers, I guess.
Yeah.
What can't you do? Where do you find yourself being like, I got to go on LCSC and buy this specialized part, silicon, I guess.
So I struggle with this question because I'll tell you the things that immediately jump to my mind, and I'll tell you
Sure.
why
Yeah.
that's irrelevant.
Gut is how we operate here. Yeah.
Battery charger.
Okay.
But this
Interesting.
chip
Yeah.
100% could be a battery charge control system.
Yeah.
I am personally a little bit too anxious to do it at this time. I still would buy a
Mm.
battery charge system,
Sure.
but totally no reason to do so. It could totally do it on its own.
Mm-hmm. Yeah.
I would say Ethernet controller, but on the other hand, who knows? Maybe in a couple months, somebody else is going to come out with a bit
Yeah.
banged Ethernet stack. I would
Yep.
say, I mean, honestly, it is a pain that like the USB, when you do low speed bit bang USB, it really is painful because it means that while you're sending and receiving frames, you can't be doing other stuff, which is,
Yeah.
that's annoying.
Yeah.
I would say,
So what we really need is we need WCH to come out with a 20-cent dual core.
oh, they are, well, not dual core, but they came out with the 035, which does have USB built in.
Oh, really? Oh, interesting.
Yeah.
Okay.
But that one's still kind of I'm still kind of eyeing it. It's not really
How much does
clear
it
how much
cost?
we don't know really. They
Okay.
haven't
Yeah.
really, it's like nominally 70 cents for some reason, but it's probably more like 40 cents, but that's still 4 times 10 cents. So,
Yeah, put two of them down on the board. I mean, that's another thing is like the multiplicative effect. You can just drop. I mean, aside from the hassle of programming multiple chips, then you could just drop another one on the board, and one could be a USB, and you could make it dual core, quote unquote, by just
I
having them,
guess, yeah.
UART between them or something,
Well, actually, it's funny you'd say that. One of the key features. This is, I think, what sort of sealed the deal for me. Like, I know where the next 6 months of my life are going with this. Was the debug interface for it. It has a single wire you hook up, and you go send it a special signature anytime you want to enable the debug part of the chip. Now the debug part is open for business. And now you can send and receive messages arbitrarily to that.
Oh
You
my
get to
god.
write into
Like
these two
like
32-bit
memory?
registers. Not
Like memory
anywhere in
write?
memory. You are
Oh,
limited
okay.
to these two 32-bit registers, but you can ferry data through those two 32-bit registers. And it doesn't, there's no like interrupt that happens. It doesn't like, I mean, it can, if you want, you can interrupt the code, but you don't have to. It can happen totally asynchronously. You can also then halt the processor and run debugging on it. You can go reflash it. You can do any of these things through that single wire. And so, like, for
Hmm.
instance, the Nixie tube thing, all of the demos that I did using that, I didn't use a UART to talk to it. I just used that debug pin because it's like, it's really convenient. It's one wire and you
Huh.
just can talk bidirectionally to the part. And like, I can say, go to, 180 volts. Well, what's your current output voltage? What's your input voltage? And like all
Oh.
of these
So it's like a
things.
control interface, more like a
Yes.
single wire control interface instead of a
It's a
just
single
debug.
wire. It's a single wire everything.
It's a skeleton key to the WCH or to the
Yeah.
CH32.
Yeah,
Yeah.
it really is. And that's one thing that like kind of was a little annoying about the 203. So WCH has this whole line of these CH32V, V meaning RISC-V again, processors, but the 003 I think is the only one that has the single wire debug interface, which is just so convenient. So,
Hmm. Hmm.
yeah.
And so, what is you said 6 months? Next month, 6 months of your life will be towards.
Oh, no. This was 6 months,
Oh,
or not 6 months.
oh,
This
this
was
was.
like
Oh, this is
4
the
months
choice
ago.
when you were making that choice.
Yes,
I see.
yes,
I
yes,
gotcha.
yes.
Got
So
it.
I've
So
spent
this
the
is the
last 4 months of
feeling
my
it.
life, like, well, not my life. I have a day job, but like the last four
Right.
months
Right.
of every bit of time that I can spend outside of work working on this, just because it's
Yeah.
been, I was like, this is time to go. So,
Hmm. Interesting. Okay, so we're past the hour mark. What I'm hesitating to ask this question because I feel like I know the answer, but how would you say? So we have a wide range of people listening to this show right now. What is the first thing people should do if they want to go and get started using the library, which is called the CH32's V003 Fun is the
mhm.
library, right?
Yes.
How do they go and get started right now and get to Blink and go start doing fun things?
So on the web page for the GitHub page for CH32V003 Fun, there's a thing where it's a link on the README that says getting started. You click on that and it has specific instructions on how to install the Windows toolchain and use it, and how to install the Linux toolchain and use it, and how to install the OS X toolchain and use it. The steps should take no more than 3 to 4 minutes to do the full setup for everything
Nice.
and have your Blink working. If you have the dev board off of AliExpress, I think you have to like run a jumper to make like hook up the LED. If you have one of my little CH32V003 fun boards, you can just immediately program. I have a little demo that runs WS2812 like NeoPixel like things, and I have
Mm-hmm.
4 or 6 of those on the board itself. So if you just say like CD example slash WS2812B example, enter, make, enter, it'll go build, flash the part, and start the part, and you have like a little glowing demo of
Yeah.
some NeoPixels doing
Nice.
some fun stuff.
That's great. Yeah, that's a great way to get to start too, because it's like having those examples there and just going through all of them, as many as you can, and just digging in, just figure out all the things that you can do first is great. Yeah.
Mm-hmm.
What is next? If you're willing to give little teasers here, what do you hope to do next with this thing? So you mentioned the last 6 months, starting 4 months ago. You got 2 months left on that term.
Yes.
What else are you doing here?
About maybe a month and a half. But the goal right now for me is take all of these things and make them really good. And I've been really trying to
Yeah,
do that. So like the USB thing just isn't quite done yet. So I have to
yeah.
really make that a first class citizen to be able to just reflash it and make it so the same level of how I described the ease of getting started. I want to be able to get there with, I don't even have a programmer. I just have the part. I want to be able to
Mhm.
work with it and stuff like that. I really want to be able to get there. And I guess the second part of that is there's already people on my Discord who are starting to write CH32V203 fun or 307 fun. And I really want to support
Okay.
them. And I really think that,
Got
I think that this is, I hope that I'm able to be some sort of like, if nothing else, I want to be some old crusty person like pointing in the direction of like, we can do this. We can live in the world where it takes less than a second to compile and test our products. We can live in a world where we aren't overburdened with having to understand all these complicated libraries and everything else that goes so deep. We can just have the code that runs and makes our projects work. And I think there's enough other people who are starting to glom onto this and starting to be like, okay, yeah, that actually makes sense. I like the idea of being able to just compile a program and run it on my part instead of needing mountains of libraries and code and other hidden abstractions in order to use the part. So yeah, I just continue to facilitate this.
That's great. No, that's a really good goal. Where can people find you online? Where can they find the Discord? How do people get in touch and watch your stuff?
I mean, I'm always available on my Discord, and I guess we should probably put the Discord link on the GitHub. I think we'll do that. Yeah, I'll make a note to make sure that goes there. So by the time this airs, the Discord link will be on the GitHub.
Okay.
And for me, I'll continue to put all of the projects that I'm working on up on GitHub and all the public projects. And I will continue to make YouTube videos about the other interesting bits that I run into along the way.
All right. Like and subscribe. Thank you, CN, for being on the show. I really appreciate it. This has been fascinating. I have no excuse now, I think. So I got to go blink some LEDs and get some stuff going on this part. So thanks for all the work you've done.
You'll be one of the early ones, so let me know if there's any problems so the next person will not have the same problem you had.
All right. Thanks for being here.
Okay. Have a great day.